Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at a very interesting topic, that is Linux from scratch. So here in this video, we will see how I have built a Linux operating system or Linux distribution with minimal packages using this documentation, that is Linux from scratch. So here in this article, we will be following the stable version of Linux from scratch, that is version 12.3 as of this writing, to build our own minimalistic Linux distribution. Okay, so I'm going to use my test environment, that is Fedora 41 workstation. So this is going to be my virtual machine on top of which we are going to build this minimalistic Linux distribution. Okay, so why building a Linux from scratch? Let us try to understand why we want to build a Linux from scratch. So today, if you look at the DistroWatch, that is a popular website for all the Linux distribution that are available worldwide. There are hundreds of distributions that are available that you can use, and all these distributions they have a different different set of tools or packages that are distributed as a part of that OS. So let's say if you take a popular operating system such as Ubuntu comes with both the Fedora. Ubuntu comes with both a server edition and a works desktop edition. So you have two different flavors with two different set of packages that are installed on those distributions, and we have different operating systems such as Fedora, which also comes with different editions like workstation edition and server edition. And we have some operating systems Linux distributions such as Kali Linux or Parrot OS, which come with a set of tools that are catering towards the penetration testing. So Linux distribution is not like one distribution which has all tools. It is built. They are user friendly. They are built based on the requirements of the user or different use cases or scenarios. Okay, so that is why here we will try to build a Linux from scratch using a set of tools which are minimally which are required as a base in order to start an Linux operating system. So there is no such thing as single Linux OS or distribution. We can customize the build, a Linux distribution as per our requirement and need by installing only the necessary packages. So that is why we will in this video we'll try to see, or I'll show you how exactly I followed the Linux from scratch documentation in order to build a OS out of it. Now let us go to our next step, that is making my own Linux LFS distribution. So the primary source of documentation to build Linux from scratch is going to be the Linux from scratch version 12.3 website. So if you go to the Linux from scratch, so this is the Linux from scratch website. So you need to go to linuxfromscratch.org, and you will see there are different books. So these are all books that are provided by this community, wherein the first thing that you can try is the Linux from scratch main book. This is a base from which all the projects are derived. So this is where we will be able to build a very minimalistic Linux operating system out of your base OS. So here if you go to read online, you will be redirected to the page wherein you will see there is a current stable LFS book which you can try to refer. So this book is very exhausting, or it is a comprehensive book, I can say, with all the details, all the steps written with details So you can follow this documentation, but Linux from scratch, if you want to build with this documentation, it is going to take a while. Like I have been following it for at least 2 or 3 weeks in order to completely understand all the steps and try to replicate it in my operating system and try to build an operating system out of it. So this is very good resource. I can say it is a golden resource which we need to follow in order to understand each and every step, each and every package that you are going to install, and what are the different options that we use in order to build a package. So you'll get to learn a lot of things with this build. So this documentation is actually a book that you can download as a PDF also. So this is a golden source with many details, as I mentioned. So why I'm writing this article? So I'm writing this article just to help all the Linux enthusiasts with the procedure that I followed, the issues that I have encountered, and the checks that we need to ensure that they are in place before proceeding with any steps in the documentation, and also to make it less daunting task and encourage you all to go for it and build your own Linux distribution. So basically, the Linux from scratch is a very good resource that everybody should like follow, and everybody should read all the documentation. And why I have written this article is basically you need to have base OS on top of which you need to install your Linux from scratch. So I'm just giving a high level steps which I have used in order to uh, s- prepare my setup, prepare my host environment setup, and what all issues that I have encountered, and what you can do in order to ensure that if you have any issues, like how you can restore back to your previous state, so that you can uh, go to that previous state and try to do all the steps that you feel that you have gone wrong. So that is why, like, I'm trying to write this article so that you can just try to replicate things and try to do the steps, and try to revert back to a previous step, so that if there is something goes wrong, you have a way to restore back to your previous good known state. This is going to be a great learning experience where you will be able to know the different packages that we are going to need in order to build our Linux distribution, and understand the details and importance of different packages that we are going to compile and install. So LFS is all about install compiling and installing all the different packages. So we will be compiling the toolchain packages, basically like glibc, gcc. These are the base packages that are needed in order to compile any software package which are written mostly in C or C++. So you'll get to know, like, what are the different packages that are there for different things. Like we have networking packages, we have ACL packages, we have grep, tar. So all these are tools, but they are also packages that you need to install as a part of Linux distribution build process. Also, it provides us with some hands-on experience with different Linux commands and tools that we will use to achieve our task. So mostly, as I said, it is about compiling, installing packages. So you will get well versed with what are the different steps that we follow in order to configure, make, and install the packages. And we will try to understand about different package build options, like configure options, that we need to like pass in order to customize our build. All these details are well written with all the information about all the options that we use in order to compile and install. They are well written in the LFS documentation. Here, like here in this article, I'm not going to show all those details, but I will be trying to refer you to the LFS documentation wherever it is needed. Now, now let us try to go to the procedure that I have followed. So as a first step, we need to ensure that we have the virtualization packages installed on our host operating system. So what I'm going to do is I'm having a host system on top of which I'll be having the KVM virtualization documentation, KVM virtualization packages installed, with which you will be able to spin up a virtual machine. Okay, so this is the documentation of the Fedora operating system, wherein you can follow how to create a virtualization environment and try to spin up a basic virtual machine and try to see if you are able to start it, stop it, and see like if you are able to create snapshots of your virtual machine and try to see if you are able to revert back to a snapshot and see if you are able to get to a state where you have created that snapshot. So this is a virtualization tools that we need to install on top of our host operating system, and this virtual environment is where we will be creating our another host system, I can say, or the base operating system on top of which the LFS will be built. So we will see like how I have done that one. So here I'm actually working on a Fedora OS installed on my x86 underscore 64 architecture platform. So this is the base platform architecture. So LFS documentation is written uh, taking into consideration different architectures, but here I'm concentrating on the x86 underscore 64 architecture only. Okay, so the reason we are doing this exercise on a KVM virtual machine with virtual tools installed is to provide with the facility of creating snapshots, which will help us with restoration to last node, good snapshot in case something goes wrong. So this is why like we are doing it in a virtual environment rather than doing it in a host operating system. Okay, so now you can look at your uh, virtual uh, your platform. So my environment has the following kernel, and this is the x86 underscore 64 architecture platform. Okay, so now in order to get the virtualization environment setup, you can just follow the virtualization guide which I have shown. This is the virtualization guide that is provided by Fedora documentation. So you can follow it in order to install all the tools needed for virtualization. Okay, and if you want to launch your virtual machine without root privileges, without root user access or privileges, you can update your current logged in user to be part of the libvirt group. So basically so virtualization tools that you install, it is going to start up a daemon that is started with the user libvirt. So basically, libvirt is uh, the the group that a user is to be part of, so that if you want to launch your virtual machines without sudo user, you will be able to do that. So you need to ensure that your current user with which you have installed your packages, it is a part of the following group. Okay. Now that we have understood like how you can install the virtualization tools, let us go to our next step, that is creating a virtual machine. So LFS documentation recommends a minimum of 4-core processor with 4 GB RAM that is needed in order to build your LFS distribution. But 4 core and 4 GB RAM is going to take you a lot of time to build the packages, because there are a lot of packages that we need to build and test and install them. And for this thing, like what I'm doing is here I'm creating a virtual machine with the following configuration. So this is the configuration that I'm using. So as I said, even though this is not the minimum, a required configuration to build the LFS distribution, it is better to allocate the build resources to your VM if possible to ensure that the packages are compiled, tested, and installed without much delay. So my virtual machine VM name is going to be linuxscratch.stack.com. It is going to be provided with 8 cores and RAM of 8 GB, and I'm going to use a 100 gig disk. So I'm going to create a 100 gig disk, and the firmware or the hardware platform that I'm going to use is going to be BIOS. And this is the ISO, the Fedora Workstation ISO. If you are wondering like where you can download, so you can go to Fedora Workstation and download Fedora Workstation, and here you will get all the links wherein you can download the Fedora Workstation. So it shows the current Fedora Workstation is of 42, but you can also download the older version also. So you can just go to the 41 path wherein I have downloaded the workstation for Fedora 41 Fedora 41. Okay, so you can just go to this index and go to x86 architecture ISO, and you will have this ISO file that you can download. Okay, so now, so you have the ISO downloaded, you know the configuration that you want to use in order to set up your virtual machine, and it's time to launch your virtual machine. Okay, so you as you installed the virtualization tools, you can use the Word Manager as mentioned in the documentation to create the VM, or you can install Boxes. Boxes is another tool that is provided by Fedora that can help you to install or launch your virtual machine from from a file, that is ISO file that you have downloaded, or you can download the OS directly from here. But you can just go to download and look for the Fedora Workstation, and it will launch a new VM with the following configuration that you can provide. So here you can see the firmware that I have selected is BIOS, and you can provide a name like Linux scratch.stack.com, and you can provide the memory as 8 GB and hard disk as 100 gig, and you can launch your virtual machine. I'm not going to launch over here because I already have that, and I'm going to show you that thing. So before we start, so once you start the installation process of the Fedora Workstation, what you need to do is there will be a set of screens wherein you need to select your language, and in the other screen that you'll get, you will need to select the time zone, the destination, the disk you need to format. So all those things you need to do. So one thing that you need to do is you need to set there. So you need to customize the virtual hard disk setup. Okay, so this is very important. You need to ensure that you create the following partitions as shown in the screenshot below, while leaving 70 gig unallocated space that will be used to build our LFS system. So as I mentioned, like I'm using a 100 gig disk, but in that 100 gig disk, what I'm going to do is I'm going to create this custom partitions. So you can see like I have created a boot, BIOS, a root partition, and a home partition with home partition. Like this is 30 gig, wherein I'm just allocating the 30 gigs of the 100 gig for the root and home partition. And here this is 1 GB for boot partition, and this BIOS boot is for 1 MB. So this is how I have customized the disk, which I'm going to format. And once you have done this customization, you will see that you have still available space of 70 gig, which we will leave it as it is so that we can use it for LFS. Okay. So I'm going to So you need to install your let me go to okay. So you need to install your VM in such a way that you have 100 gig GB with in that 70 GB is unallocated. Okay. So once that customization of your disk is done, you can begin your installation. Once your installation is completed, there will be a screen that you will need to complete the setup for user. So you can create a user with root privileges and set up the password for that one. Once you logged into the Fedora workstation, just ensure that you have updated all the packages with the latest version to ensure that you are up to date and your partition configuration looks as below. So once you set up the user, you can log into your workstation and you can do sudo dnf-y update so that you get the latest packages downloaded and updated on your workstation. And you can also and you need to run the lsblk, that is list blocks, in order to see like what are the different partitions that are created on your hard disk. So we have the root partition, we have the home partition, we have boot partition, and we have this BIOS boot partition, that is 1 MB. Okay, and we have still 70 gig which is still unallocated that we can use for LFS. So LFS is usually installed in a dedicated partition. So that is why like we have left that 70 gig space so that we can create that partition and try to use it for LFS build. The recommended approach to building LFS is to use any available empty partition, or if you have enough unpartitioned space, to create one. So this is what the LFS documentation suggests. So you can use an available empty partition if it is available. So this is what that we are doing. We are making sure that we have available empty partition, or you can, or if you have enough unpartitioned space. So we have available space which is unpartitioned. So this is what we are going to use in order to build the LFS. But let's say if you have built if you have already existing workstation or virtual machine that is installed, you have another option also wherein you can create a disk, virtual disk, and attach it to the virtual machine and try to format that virtual disk. So that is going to be a different procedure that we are not going to look at in this demo, but that is also an option that you can follow. Okay, so here we have created a partition on the existing disk, that is dev slash vda of 70 gig size as shown below. We will require the partition to store all the source tarballs and compile the packages. Usually 30 gig partition is a reasonable size to provide for growth. So this is what LFS recommends. Like you can have just 30 GB partition, that is enough to build all the packages, and you can extend on that also in case you want to do additional packages installation. But we have 70 gig, that is more than enough for this demo. Okay, so this is again the same thing. 30 gig is provided is to provide sufficient free temporary storage as well as for adding additional capabilities after the LFS is complete. But compiling packages can require a lot of disk, which we will reclaim after the package installation. So compilation is a time consuming task, and it is also going to take up your space. So that is why they recommended a 30 gig space, but you can allocate 70 gig so that in case you want to extend your LFS, so there is an extension to LFS which is BLFS, beyond LFS, wherein you install different packages depending upon the use case on for which you are building your OS. So if you're building a workstation, you will install different set of workstation related packages. If you're building a server, you will install different packages related to server. So that is the case. Okay, now let us create the partition named LFS on the unallocated 70 gig space, which we will use to build our LFS. Let's see. So now let's see the file system. We will set the file system as ext4. that we will create the partition on. Okay, so if you see, so this is, we need to do this partition using the root user. So I'm switched to root user, and we need to run the parted /dev/va. So this is our uh, disk on which we have unallocated space, and you can provide the partition name, file system name, and the start and end uh, values for this partition. So I'm starting my start value as 20 gig, 29 gig, or 30 gig you can provide, and the end value as 100% to use the complete unallocated space. So once you provide these details, it is going to create that partition for you, and you can now run the lsplk command again to see that partition has been created. So you have this 70 gig partition created. Now what we need to do is we need to create a file system of type ext4 on this partition as shown below. So this is we are doing with mkfs command, wherein we pass the type, that is ext4, and we pass the partition that we have just created, that is /dev/vda4, and this is going to create a file system of type ext4 on that partition. So once our file system is created, it is time to mount our partition and update the etc fstab file so that it gets mounted on reboot. So here we are creating a mount point directory. So in order to mount our partition, so first we need to create a mount point directory. So we will create a mount point directories as /mount/lfs, onto which we will mount our newly created partition, that is /dev/vda4, with the file system type as ext4. Okay, so here, like you can see, like I have created the directory /mount/lfs, and here like we have used the mount command in order to mount our file system onto /mount/lfs. So you can see the the partition has been mounted to mount LFS. So the same thing we can do with etc fstab so that it can be mounted on every reboot. So you can just update your etc fstab file with the following line, which will mount the partition at this mount point, and this is the type of the file system, and these are the options that we pass to the mount command, and these are the different options. These are the options that we pass to this line so that we will be able to mount it on reboot. So once that is done, LFS system that we are going to build does not support SLNX feature. Okay, so here, like whatever LFS system that we are going to build, it does not support, we are not going to install anything related to SLNX. So one thing we need to ensure that we disable the SLNX on the host system, that is the virtual machine that you just created. You can just disable the SLNX feature so that we are not going to have issues later on when we mount the LFS system, especially like when we build the install the attribute package and we try to test some test cases, we will get failures if your LFS host system is enabled with SCLinux. Okay, so here like you just go to etc SCLinux config file, and you can just update the SCLinux as disabled and restart your machine. Okay, now it's time to reboot your system and verify that you are able to log in and validate your new file system is properly loaded. Okay, if everything looks good, you can take a snapshot of your virtual machine using this varsh snapshot create command and passing your virtual machine name and the snapshot name. Okay, so this is a very good thing that you get it from virtualization tools. You can create a snapshot of your virtual machine, and in case something goes wrong, you can just revert back to that state and start from there. Now let us go to our next step, that is required softwares on host system. So LFS is all about building the packages and installing the packages, and here like we are going to install a set of required packages in order to set up our LFS system. So we need to ensure that the host system that has the following software versions installed. Also, many distributions will place software headers into separate packages, often in the form of devel package or dev packages. We need to ensure that we install those if the distribution provides them. Okay, so this is the list of all the packages that are needed in order to build the LFS system. And here you can see we are going to build a kernel also for our LFS, and this is going to be very important task. And GCC and glibc that GCC basically provides the compiler, CC++ libraries that we will be using in order to compile and install our packages. Okay, so you can so how we can check all the packages that are required are installed on our host virtual machine. Okay, so and also like the symlinks mentioned above are required to build the LFS. So there are comments that are provided wherein the symlinks needs to be provided. So let's say if you have bin sh, it should be a symlink to the bash program. So like this, all the symlinks that are mentioned are required for the to build the LFS system using the instructions contained within this book. Symlinks that point to other software such as dash, MOC, etc. may work but are not tested. So you need to ensure that all the symlinks that are mentioned are exactly as they are mentioned. Okay. Now let us go to our next step, that is step 4, verifying softwares installed on the host system. So here like we are going to create a script that will verify the softwares, the versions that are installed on our host system that are required for the LFS build, and output an error in case it does not find the required packages. So this is the version check.sh file that you need to create on your host system or virtual machine, right? And then you can run it, and it will provide an output of all the required packages if they are available on your machine or not, and all the siblings are available or not. So as you can see, my version check command has failed with some errors which we need to fix. So you can so I have installed the following packages and did a symlink for bson to YACC, and then did a version check which has provided me the clean results. Okay, so this is how you need to do ensure that all the packages, required packages are available on your host virtual machine, and then only you can proceed with your next steps. Okay, so LFS is designed to be built in one session. That is, the instructions assume that the system will not be shut down during the process. Okay, so the LFS documentation mentions this, like you need to build it in one stretch, but it is going to take approximately 30 to 50 hours based on your CPU and memory resources. But does not mean that the system has to be built in one setting. The issue is that certain procedures must be repeated after a reboot when resuming the LFS at a different point. So it's not mandatory for you to like build your system in one stretch, but in case you reboot your system, you need to follow some set of validation steps, so that when you are trying to build another package after the reboot, those prerequisites are met, such as the LFS variable or environment variable is set, and all the required virtual file systems are mounted or not. So those kinds of checks you need to ensure you make if your system is rebooted, and once you have ensured that all the prerequisites uh, are in place, you can proceed with the package installation. Okay, now let us go to our next step, that is step 5, set LFS environment variables and EU mask value. Okay, So the LFS environment variables will be used throughout the LFS build process. We need to ensure that we set this to the name of the directory where we will build your LFS system. Okay, so this is a directory that wherein we have mounted the file system or the partition, and this is we are going to set this as an environment variable in the bash rc script for the root user. So for the root user, you can just go to this bash rc script and add this line export lfs is equal to /mount/lfs, so that whenever a root user tries to do some activity, they will be automatically having a reference to this lfs variable. And similarly, you can do the same activity for the current logged in user, that is admin in my case. You can go to the admin users bash rc script that is available in this home directory, and you can add this line. Okay, so that so whenever you are going to relaunch your session or reboot your session and try to access it into your terminal either as a root user or the lfs user, you have this lfs variable set as required. And also, like we need to ensure that the file mode creation mask is set to 022 in case the host distro uses a different default for both current user and root user. Okay, so you need to ensure that your umask value is set to 022 both for the root user and the normal user. You can just ensure that this is the value. Okay, now let us go to our next step, that is step 6, file system ownership. Okay, so here we need to set the ownership and owner and the file system mode of the LFS directory, that is the root directory in the newly created file system for the LFS system to root and 755. So whatever LFS mount or directory that we have created, that should be owned with root user and the permissions should be 755. Okay, so this is how your mount file system should be having the ownership and permission. Now let us go to our next step, that is download packages and patches. Okay, so here like the LFS documentation provides with a list of packages that we are going to install. So these are going to be the list of packages that we are going to build and compile. Okay, and there are some patches also provided for a set of packages that you will be installing as a part of build process. So all this information is provided in the LFS documentation. Here what we are going to do is we will download all this list of packages and some patches that are needed to build a basic LFS system into the LFS sources directory, and can be used both as a place to store the tarballs and patches and as well as a working directory. So this is going to be our main location wherein we will be like downloading our packages, and we will be also extracting, building and installing the packages from. Okay, but by using this directory, the required elements will be located on the LFS partition and will be available during all the stages of building process. Okay, so what we are going to do is we are going to create this directory LFS sources, and we are going to provide it with all permissions. We are going to provide with the right permissions for all of them. Okay, so this is how your mount LFS sources directory permissions are going to be updated. So as you can see, everybody can write it to this source directory. Now let us try to download our packages. So this is the location of all the packages. So if you try to open this, so it shows all the list of packages that we will be downloading from various sites. If you have any issue with any site, like you can just try to Google and try to look for a mirror site from where you can download this package, and you will be able to download all these packages. But there is one package that is not available, the expac package with the following version. So you need to download this from a different site. So here, like as I mentioned, like I have used the GitHub page in order to download that package. Okay, so that has actually downloaded the package, but yeah, so that is where like I have downloaded that missing package from the list, so that we have all the packages. So as I mentioned, if you face any issue downloading other packages, you can always try to download it from mirror side by updating the wget list sysv list manually, and you can uh, download all the source packages. So once that is done, it is now time to take another snapshot of your virtual machine, and you can stop your VM and take the snapshot. So here, like you can just mention your snapshot name as downloaded packages. Okay, so before proceeding with the next steps, ensure that you have started your virtual machine and you are logged in with a root user. Also ensure that the LFS environment variable in UMass values are set as per in the as done in the previous step. So this is very important. Before you proceed with any build process, you need to ensure that your LFS variable is set and your UMass value is also set. Okay, now let us go to our next step, that is step 8, final preparation for the host system. Okay, here we will be performing a few additional tasks to prepare for building the temporary system. We will create a set of directories in the LFS in which we will install the temporary tools and add an unprivileged user and create an appropriate build environment for that user. So what we are going to do is we are going to create this. So this is something that this is something that you can follow from the documentation also. So if you go to this final preparation chapter 4, so you can see we will perform few additions. So this is what like I'm doing exactly in the my article. So we begin by populating the LFS system with the pieces that constitute the final LFS system. So this is what exactly I'm doing. So chapter 4 and chapter 5 need to be run as, so if you go to okay, so this is building LFS in stages. So chapter 4 and chapter 5. Chapter 4, this chapter runs the commands on the host system when restart. So procedures performed as root user after section 2.4 must have LFS variable set. Okay, so this is very important. Uh, so so whatever commands that we are running after the section 2.4 must have the LFS environment variable set for root user. So in this, what we see is chapter 4. So if you go to chapter 4, so all these commands that we are going to run is going to be run as root user. Okay, so here like you can just create your directory structure, and this is something that you need to run in order to create the symlinks and create a directory for create a directory for lib64. Okay, so once you have created that, you can just do ls-ltr on your mount point, and you will see all this directory structure has been created with all the symlinks. Okay, so once that is done, you can create this tools directory also. So LFS has deliberately decided not to use the user lib64 directories. Several steps are taken to ensure that the toolchain will not use it. If for any reason this directory appears, either because you made an error or because you installed a binary package that created it after finishing LFS, it may break your system. You should always be sure that this directory does not exist. Okay, so this is something that LFS mentions. So they are not going to use lib64 for anything, but all the lib packages will be in the lib. If there are something in the lib64, they will be referenced from the lib folder using the symlink. Okay, so now we are going to add user, that is LFS. So for that, first you create a group, that is group using group add. We create a LFS user. Then we use user add to create a user named LFS who is a part of group LFS, and he's going to have access to the shell, that is bin bash. So once that is done, you can change the password for that user using the passwd LFS, and you can just provide the credentials for that one. Now we need to grant LFS full access to all the directories under the LFS. Okay, so for this, what we are going to do is we are going to change the ownership for all the directories that we have created to LFS, so that LFS will be able to write content into those files. So this is how we are going to do that. So next, start a shell running as a user. This can be done by logging in as LFS user or with the following switch command. So you can, if you're running as root, you can just use switch user to LFS and you will be switched to LFS user. And here, like, we are going to create this bash underscore profile with some environment variables, and we'll be launching our bin bash. Okay, so you can see the home directory for our LFS user, that is going to be home LFS. And if you print the environment variables, like, you will see the home directory, the working and the term has been set. Okay, and now the new instance of the shell is a non-login shell, which does not read or execute the contents of the etc profile or bash profile, but rather reads and executes the bash rc file instead. So create this file. So we need to create this file for this LFS user with all this environment variables. So this is very important, LFS underscore target, wherein the cross toolchain packages are going to be installed. And we are setting this path to LFS tools bin. And we need to export all these variables. Okay, so once that is done, to use all the logical cores available for building the packages in chapter 5 and chapter 6, set the make flags in bash rc. So this is very important. So if you have multi-core processor, you need to ensure that this variable make flags is set so that your build and installation procedures is going to use all your cores when they are building, and it will reduce your time of build. Okay, finally, to ensure that environment is fully prepared for building the temporary tools, force the bash shell to read the new user profile. So whatever user profile that we have created, we need to ensure that it is sourced. So you need to source this so that all these variables that we have set in this are getting activated. Okay, so this is what the bash rc command looks like. And once you do print nv now for the current LFS user, you'll see all these variables are set. Okay, now it's time to understand what is SBU. So SBU is basically a relative measure of software compilation installation time. So when you start the LFS build process, the first package that you are going to build is bin utils. Okay, so in layman terms, what we can say what an SBU is. So whatever time you take in order to build bin utils is going to be the SBU. One SBU is going to be the SBU value. Okay, all other packages that you are going to build, they will be time to build that package will be related to this SBU value. So let's say if your SBU value for uh, building the binutil packages is 5 minutes or 6 minutes, and let's say if you're building a GCC package which requires some like 43 minutes, so 43 SBUs, so you need to calculate is it has 43 into 6, and whatever minutes you get, that is the time that it takes in order to build your GCC package. So that is what all SBU value is all about. It is a measuring unit. And test cases. So test cases are very important when you run the build and compile, test, and installation in the ch root environment of the LFS package, LFS system. And there are some test cases that we need to ensure that they are run and all the test results are as per the LFS documentation that I have mentioned. Okay, so this is so there are some packages like GCC, Binatrial, or glibc that are of utmost importance due to their critical role in the properly functioning system. The test suites for GCC and glibc can take a very long time to complete, especially on slower hardware, but are strongly recommended. So until this point, we have covered most of the So until this point, we have covered most of the part that we are required to be carried out from part 1 and part 2 of the LFS from scratch book. Okay, so let us now head towards part 3, that is building the LFS cross tool chain and temporary tools. This part is basically divided into 3 stages. So first, we are going to build a cross compiler and the associated libraries, and then using this cross tool chain, using this cross tool chain to build several utilities in a way that isolates from the host distribution. So what exactly we are doing is we are going to build a set of tools or cross compilers that will be only specific to our LFS system, and they will be isolated from the host system. So that is what the cross compilation is all about. And once we have all the tools ready in our LFS mount point that are isolated from the host system, we can enter into the ch root environment and construct the remaining tools needed to build the final system. So this is the final step. So if you go to the LFS toolchain build, so these are the first set of tools that we will be compiling. These are the cross toolchain, and once that is done, we will be additionally compiling all these cross temporary tools, and then we will be entering into the ch root environment and building all these remaining temporary tools. So this is what the part 3 of building the LFS cross tool chain is all about. Okay. So before proceeding, so let's now go to our next step, that is step 9, general compilation instructions and checks. Before proceeding into the cross compilation of packages, let us ensure that the host system requirements, including symbolic links, have been properly set. So before actually trying to start with your cross compilation, you need to ensure that all these packages or all these tools are available on your host virtual machine. So you can see we have bash, we have sh, that is a link to bash, we have awk, that is symlink to gawk, and we have yacc, which is a symlink to bson. So this is pretty much very much needed for the cross compilation to work. So here are the generic instructions that we need to follow for each package that we are going to compile and install. So compilation and installation is basically a procedure wherein we change into mount LFS source directory, wherein we have downloaded all the packages. And in general, what we are going to do is we are going to use this Dart program to extract the packages. In chapter 5 and 6, ensure that you are the LFS user when extracting the packages. Okay, so for chapter 5 and 6 in the LFS documentation, we need to ensure that we are doing all this process with the LFS user rather than the root user. Do not use any method except for the tar command to extract the source, notably using the cp-r command to copy the source tree somewhere else can destroy the timestamp in the source tree and cause the build to fail. Okay, so once you have extracted the tar file, change it to the directory which has been created and follow the instructions for building the packages. And change back to the source directory where the build is completed and delete the extracted source directory unless instructed otherwise. Okay, so this is the generic steps that we are going to follow for each package that we are going to build as per the documentation. Now let us go to our next step, that is step 10, that is compiling a cross toolchain. Now we need to enter into the LFS chapter, that is cross compiling a toolchain. Okay, so this is where you will start building the packages. The first package that you are going to build is binutils. Okay, so you need to go to the source directory, you need to unpack, ensure that you are with the LFS user. The cross toolchain packages, that is chapter 4 and chapter 5, are going to be done with LFS user. Okay, so extract the package, change into that package directory, and we need to follow the instructions. So let's say this is binutils, so I'm going to go to the binutils page which shows the instructions for build and install. So as you can see, so once you are into this page, you automatically need so you need to extract the package, and all the instructions that are provided need to be followed after the package extraction and changing into that directory. So after the package extraction and changing into that directory, you need to follow all these steps: create the build directory, configure, and make install. So you have been provided with all the information related to all the options that we use for the build steps or the configure steps in detail on the LFS documentation page. So once you complete the binutils, like you can go to the next page and you need to compile the GCC. So this is how all the steps for the cross toolchain needs to be completed as a part of this process. So here, like you can see, the part 5, this chapter 5 has all these packages that we need to build and install. Okay, so here I have shown you the steps that I have followed to build the binutil packages. And once you have completed the make install, you can change back to your source directory. So you are in source directory and you can remove that binutils package that has been extracted. So this is something that you can do for all the packages that you are building and installing. So once you build and install, you can remove the package. You can keep the package as well, but not needed. It is going to take up your space. So remove the package. The above compilation and installation took approximately 6 minutes on an 8-core processor. This is going to be the base value for one SBU. So this is what the SBU measurement is all about. So for this binutil packages, it took me 6 minutes on an 8-core processor. All the package compilation and installation will be based on this value. So that is what this SBU value measurement is all about. So once that is done, continue with the cross compilation of the cross toolchain for all the packages listed in the LFS chapter 5 linked below. Okay. So once that is done, let us go to our next step, step 11, that is building additional packages. Okay. So now, so let's see. Let's go to home, and we have completed our cross toolchain, that is required packages. And now we are heading to cross compiling temporary tools of chapter 6. Here we see how to cross compile basic utilities using the just built cross chain. Those utilities are installed into the final location but cannot be used. Basic tasks still rely on the host tools. Nevertheless, the installed libraries are used when linking. Okay, so these utilities that we build here will later be utilized after entering the ch root. Okay, so we are going to compile and install another set of temporary tools which are later going to be used in the ch root environment. So for this, you can just go to cross compilation of temporary tools. This chapter shows how to cross compile utilities using the just build cross toolchain. Okay, once again, so you need to ensure that improper set of LFS together with the once again, let us recall that improper setting of LFS together with building as root may render the system unusable. So you need to ensure that chapter 5 and chapter 6 are to be completed with the non-root user. This whole chapter must be done with LFS user with the environment variable as described. Okay, so whatever packages that you are going to do as a part of install build and package, so this is what the list of packages that we need to do, the compilation and installation we all need to do with LFS user only. Okay, so chapter 5 and chapter 6 we are building a cross toolchain package in our source in our LFS mount, so that they can be later used in the building another set, building the actual set of packages from the ch root. Okay, so once you have completed all these packages build and compilation and installation using the LFS user, you can proceed to chapter 7, that is entering the ch root. Okay, so now so now that we have completed the chapter is step 11, cross compilation of temporary tools, let us go to our next step, that is step 12, entering the ch root and building the additional temporary tools. So this is LFS chapter 7. I'm going to close all of this. So this is chapter 7, entering the ch root. This chapter shows how to build the last missing bits of the temporary system, the tools needed to build the various packages. Now that so with the chapter 5 and chapter 6 we have installed all the required dependencies, and we have ensured that all the circular dependencies have been resolved. Now it's time to enter into a ch root environment completely isolated from the host system. So this is where the actual package installation takes place in the ch root environment, that is in your LFS system. Okay, for proper operation and of the isolated environment, some communication with the running kernel must be established. This is done with the so-called virtual file system, which will be mounted before entering the ch root. So this is very important. So for proper operation, some communication with the running kernel must be established. This is done with the so-called virtual file system, which will be mounted before entering the ch root. Okay, you may want to verify that they are mounted by issuing the following command: find mount. Okay, change ownership for LFS. So now like you can see the current directory structure will be like this. So we have done all the activity with LFS user and we have installed the toolchain packages, temporary toolchain packages. Now what we need to do is we need to ensure that all the directories ownership is changed to root. Okay, so this is what you need to run in order to ensure that all the directories that are with LFS user are changed to root user. Okay, so once that is done, if you do ls-ltr on your mount, you will see that all are owned with root. Okay, and the next very important thing is preparing the virtual file system, virtual kernel file system. Applications running in user space utilize various file systems created by kernel to communicate with the kernel. These file systems are virtual, no disk space is used for them. The content of these file systems reside in memory. These file systems must be mounted in the LFS directory tree so the application can find them in the chroot environment. So this is very important. We need to ensure that the file systems are mounted into the LFS directory tree so the application can find them in the chroot environment. So this is what you need to run in order to ensure that all the file systems are mounted. And there is one more mount that we need to create, that is for LFS dev file system. So you can do it with the following command, that is bind mount. Okay, so once all the so this is actually I have created the directories for the file system, and then we started mounting the dev file system, and then we started mounting the all the different virtual kernel file system, that is dev pts proc file system, sys file system, and temp file system, and the dev shm file system. Okay, so this is what you need to run so to mount your dev shm file system. So once you have all the file systems mounted, you can verify it using the find mount -n, and under the mount LFS you will see all these file systems are mounted as it is. Okay, so now it's time to enter into the chroot. So this is something that you need to do. Ensure the LFS variable is set, all the mount file systems are the virtual kernel file systems are mounted. So these two things you need to verify every time you reboot a system and you enter into a chroot environment in order to build the packages. Okay, because chroot the packages that we are going to build in the chroot environment are going to be a lot of packages. Now that all the packages which are required to build the rest of the needed tools are on the system, it is time to enter into the chroot environment and finish the installing the temporary tools. This environment will also be used to install the final system. As a root user, run the following command to enter into the environment populated with nothing but temporary tools. So here is the chroot command that we need to run. We are going to enter into the LFS mount as the root directory with all this environment variables set. Okay, so you can see the path has been updated, the makefile has been updated, the test suits flag has been updated, and the bin bash has been updated. Okay, so these all things will refer to the files that are available in the LFS directory itself. From this point on, there is no need to use the LFS variable anymore because all the work will be restricted to the LFS file system. The chroot command run the bash shell with the root directory set to LFS. Okay, so that is what the chroot environment is all about, and you can just check the path environment variable. It points to user bin or user sbin, that is within the LFS mount directory. Also note that the bash prompt will say I have no name. This is normal because the etc password file has not been created yet. Okay, so you will see this when you enter into the chroot environment for the first time, but that will be gone as soon as once we create a user in the passwd that we are going to look in next steps. Okay, so it is important that all the commands throughout the remainder of this chapter and the following chapters are run from within the chroot. If you leave this environment for any reason, rebooting for example, ensure that the virtual file systems are mounted, explained in the mounting and populating the dev section, and enter the chroot again before continuing with the installation. Okay, so now we are going to create some additional directories in the chroot environment, and we are so once that is done, so this is some additional directories that we are going to create in that. So this is basically following the file system hierarchy standards of the Linux. with which LFS is like adhering to. So LFS is trying to create all this directory structure within the chroot environment that is compliant with the file system hierarchy standards. So once that is done, you can follow this with the documentation also, and creating the essential file system links. So we need to create this file system links and update the etc host file. Currently we are setting it with the local host, so that is fine. That means that we need to update it later on when we actually reboot the system. Okay, so here like we are creating the etc passwt file with a root user and then shell, and we are creating a etc group file with a root group, and now we are also creating a test user, and we are adding this tester to a group and installing the tester. So once that is done, it is time to again re-log in into our bash shell, and once you have created that user, that I have no name should be gone, so you will get a root name now. So once that is done, you can create some additional set of folder structures and change the ownership, change group and mod for those, and build. So once all these prerequisites are done, you can just start with the building the get text. So this is all available in the chapter 7. So if you go to instructions, changing ownership, preparing a virtual file system, entering into chroot, creating directory structures, creating essential files, all this is done in the documentation. And once that is all prerequisites are done, you just go to building the packages. So so right now we are at this point in the chapter 7, wherein you need to run all this build installation of these packages under the chroot environment. So once that is done, we are ready to take a backup of our all the temporary tools that are needed to build the rest of the packages to build a Linux file system that is ready. So it is time to clean up and save the temporary system. So we need to run these commands in order to do the cleanup. So if you go to the LFS documentation, so once you do all the packages build, you can go to cleanup and saving the temporary system. So this is what you need to do as a part of chroot in the chroot environment. And once it is done, it is time to take the backup. So in step 14, so what we are doing is we are taking a backup of our. So first we need to get out of the chroot environment on the host. So get out of the chroot environment as a root user on the host system, and the following on the to unmount the virtual kernel file system. So we need to get out of the chroot environment, and then we need to do a mount of all the file system, and just ensure that you have LFS and home variable set, and you can cd into the LFS directory and do a tar of your home. Do a tar of your mount LFS, all the things that are available in the mount LFS. You can create a tar file of this name in your root directory. Okay, so once that is done, you will be able to see this tar file created with size of approximately this, and this is something that you can try to restore it again in case something goes wrong in the further steps. You can just restore it and try to start from there. Okay, so this is how you can just restore. You can just go to LFS directory, remove everything in that LFS directory and extract that package. So now it is time to take another snapshot, which can be used to restore to that point using the virtualization tools feature. So once that is done, now that is we have done the rest, looked at the restore commands also. Now it is time to look at building the LFS system, that is chapter 6. So building an LFS system is part 4, which consists of chapter 8, 9, 10 and 11. Okay, so this is now here we enter into the part 4, wherein we will build and install all the basic system softwares under the chroot environment. So following chapter 8, installing basic system software to install all the basic software packages needed for the LFS system under the chroot environment. Okay, so we need to go into this chapter 8 and install all the packages. So these are the packages 8.3. so if you see, there are a lot of packages that you need to install. So all these packages needs to be installed by following all the steps in that for that package. So let's say if you open the Vim, you need to extract the Vim package, get into that directory, and then run all these commands. That is how like you will be able to build and install all these packages in the chroot environment. So once that is done, you can take another snapshot of building uh, the basic system software, and you can restore to that point. So once that is done, so once you have installed all these packages, next comes the system configuration, that is chapter 9. So system configuration is all about creating a set of configuration files. So here now we are entering into system configuration. So we are going to build LFS system based on system v in its script. So there are two types of Linux system startup that we can do. One is system v init, that is the old traditional way of starting up a system, and the other one is system D. But here for this LFS build demo, like we are going to stick to the LFS documentation, and we are going to use the system v init scripts to start up the boot process. Okay, so let's install that package. So this installation package is available at the following documentation, LFS boot script. So you can just install that package as per the documentation instructions, and then now it's time to configure the network. So you can just in the chroot environment only, you can go to this directory and create ifconfig.h0 with the following configuration. So there is some issue. So if you go to the overview of the devices, there is a good information that is provided on how the devices are detected or managed. So this is very good information that you need to go through and read completely in order to understand how the LFS system is able to detect your devices and name your devices. So one issue that I have encountered is, like, I have created my H0 network configuration file with the following configuration, but when I have booted my system, the network has been configured with the default interface name that it has took, which is as per this documentation is correct, because I was not using the configured any set of rules like custom rules in order to provide a custom name for my interface. So that is one failure that I have encountered. So this is fine for now. Like if you do this, it will fail basically when you log in. But yeah, so this is what I did, and then I have configured the DNS. So we need to create that etc result.conf file. You can just do enter these two lines with the name server, that is a Google DNS server, and then we need to configure the host name. We can create a etc host name with the following host name, that is LFS. Then we can configure the host file, that is we need to create the host file with our IP address and fqdn, that is LFS lfs.stack.com. I think you just need to remove this thing. This is not needed, and these are the lines that you can keep it for localhost. So once that is done, you can create this profile file, which refers to the language that local that will be used. So we need to update this part, export lang with the correct local. We are using the standard en_us local that we have installed as a part of package installation. Okay. And once that is done, we can create this input rc file. So this is basically a file that you can create and keep it. This is basically for readline package, if I'm not wrong. So this is something that you can keep it for reference to the readline package, and then you can create the etc shells file. So this is what I'm using as a part of this shell file, and then we can configure the sysinit v script. So this is very important over here. So init tab is the file that when a system is rebooting, we are using the sysv init process. So the main program in that sysv init process is init, and that init process is going to refer to this file for configuration details. And as you can see, like, we want to reboot our system in the run level 3. So you can get more information on all the run levels in the documentation of the LFS. So if you go to system configuration chapter 9, and you can go to introduction, and you will see the system v init run levels description over here. Okay, so once that init tab file is created, you can just again now configure the system clock so that it picks up your local time system rather than the UTC, and you can customize the boot and shutdown scripts. So basically we need you can do that customization using the etc sysconfig rc.site, and you can update these as per this customization that has been mentioned, but it is not mandatory. It may be followed, or you can ignore it, but you can just read through this documentation to understand what exactly that options do. Okay, so once that is done, normally all the files in so once that is done, you can go to the next step, that is step 18, making the LFS system bootable. Okay, so this is basically the chapter 10 of the LFS documentation, wherein now that our chroot environment is fully configured with all the necessary configuration files, we need to create the etcfs tab file with all the required mods for the new file system. So until now, what we have been doing is once we log in into our virtual system, we were manually trying to verify if all the mount systems were available or not, like the kernel file systems are available or not. But you can do what we need to now do is we need to automatically mount them as a part of system reboot. So for that, we need to create this etcfs tab in the chroot environment of our Linux file system or the LFS system. And here, like, you can see the partition that we have our LFS system built is /dev/vdf4. So that is going to be our root partition with type ext4, and you can like mount the ZRAM swap, but I'm not using that right now. So you can just comment it, and you can mount all the other file systems, that is proc, sysfile, sysfs, dev, temp file system, and C groups. So this is how, like, you can create your etcfs tabs so that you mount all the file systems from your host system into your chroot environment. Okay. So once that is done, we need to go to our next step, that is, so we have completed the system configuration, making the LFS system bootable, And now it is time to look at building the Linux kernel. So this is going to be very critical and very important because this is something you can go wrong when doing the configuration. So let us try to go to the Linux package page. So first thing that we need to do is we need to extract the Linux package in the chroot environment, then change it to directory and clean up the directory structure. So you need to run this make proper, and then now let us create the kernel base configuration file. So base configuration file can be created using the make def conf file, which will create a configuration file and store it locally. So this is how it is going to create and store it locally. Once the configuration file is created, we need to customize it as per the LFS documentation by launching the X terminal for the kernel configuration. Okay, so once you have created that base configuration file, you can run this make menu config and customize the Linux kernel configuration as per this documentation. So wherever you see star, you need to ensure that that has been enabled. Okay, so you can go to general settings and go to CPU task settings and ensure that this is checked or not and enable it. And there are in the terminal itself, like you will be provided with the top level options which you can use in order to select or deselect the option, or how to navigate your the menu system. Okay, so it is very important that you take note of all the options that are enabled as a part of this kernel configuration. And you need to do this for 64-bit system. You need to enable these things. And if you are building it for 32-bit system, we need to do this, but we are not doing that, so we ignore that one. And we are not using the NVE file system amount, so we ignore this also. Okay, because we are using a virtual file virtual disk file, so we ignore that one. So you can go through all these things and understand what exactly those options are that we enable in the kernel configuration. And once that kernel configuration is done, you can run the make to build your kernel package, and it will create an image of your kernel that is available at this location. And now it is time to install the module. So you can do make module install, so that you can install all the modules that are available as a part of kernel. Once it is done, it is time to copy all the images that have been built as a part of compile and installation process. So we copy this VM Linux image, the system map file, the config file that we have created, and the documentation that is needed for kernel. Once it is done, this is something that we need to do for the USB part in order to ensure that the modules are loaded in the correct order. So this is modprop.d directory, wherein we are creating this usb.conf file, which provides with the instructions on how the modules needs to be loaded. So once that is done, you can take another snapshot, so that in case something goes wrong with your kernel configuration, you just have a point wherein you can restore your system back to and try to reconfigure. Okay, so once that is done, the next step is install grub for boot process. So this is very important. So this is where your system transition gets. So basically you are making your virtual host system, that is the Fedora system on top of which you build your LFS system. So you are installing the grub bootloader into the dev VDA file system, and you are providing this grub configuration file. So this is very important over here. You need to set the root as hard disk 0 that is dev /dev/VDA hard disk, and under that the partition 4 that is VDA4, wherein we have copied the VM liners and all the configuration files and the system map files are available. So we need to make sure that the grub bootloader is able to find that in the hard disk /dev/VDA4. Okay, and you need to ensure that this menu entry is also updated. So it take a note that we are referring to /dev/VDA4 to read the partition, that is the fourth partition that we have created on the file system. Okay, so once that is done, you can just go to create this LFS release to ensure that it is the system that we have built, and we can just set the password for the root user, so that when we first reboot, you can log in with the root user. Okay, so now in the step 21, so all this thing that I have shown you is available in the documentation. So you can go to the chapter 9, that is system configuration, and you can do this managing devices, network configuration, and system B, boot script usage and configuration, local configuration, input RC, and shells. All of this is covered in my blog. Okay, so once that is done, so we have created the FS tab file. We have built and compiled and configured our Linux kernel, and this is basically a documentation related to grub, like how it works, and then it's time to reboot our system. Okay, so before rebooting our system, you need to ensure that the password is set, so that we have done. So this is what we are following. So once that is done, we can exit the chroot environment and unmount. So now we are still in chroot environment, but you can now log out of your chroot environment and unmount all the file systems that we have mounted manually, and now it's time to reboot your system. So if everything goes correctly as per what have been mentioned in the documentation and what I have tried with my blog, you should be your grub bootloader is installed and configured with the disk information, where to look for the VM liners image and other details, and we are ready to reboot our system. If everything goes as planned, you should be able to see an entry to select your new Linux distribution with the version 12.3. So this is what your first screen will look like. Once you select the version, you will be taken to a login screen wherein you will be able to log in. But as I mentioned, there was one issue that I have encountered with relating to network file system that failed to start up. So what I had to do is I need to rename my network configuration file that I have created in etc sysconf file after login to ifconfig.enp1s0. That was the name that it picked up with this static configuration, and I was able to bring it up with if up and passing this network interface name. So if that is working, then you can just reboot your create this configuration with updated configuration, create this configuration file with this updated configuration, and you can just reboot your system and you should be good to go. So you can see all these checks are okay and the network file system has come up. Okay, so you can just once you log in with root user, you can just verify the host name, that is LFS, that we have set, and you can verify the etc LFS release file that we have created, that is with 12.3, and you can also check the mounts that are available. So these are all the mounts that are available on your LFS system. So this is what, like, you can try it out. This is going to be a very time consuming task or a daunting task, I can say, which needs your resources, time and patience. And the virtualization tool is going to be of a great help, so that you can do it in multiple settings. So you need not go and do it in one shot. But there are a few packages that are going to take a lot of time to build and install, build and compile, basically like glibc or gcc. But yeah, there are only like 3 or 4 packages that might take more time, but otherwise, like most of the packages are going to be completed very quickly if you have a very 8 core processor like as I have right now. Okay, so I would highly recommend you to go through all the LFS documentation, as that's the detailed documentation providing detailed information for each step that we do as a part of LFS system build. And finally, you can take another snapshot of your virtual machine, stop the VM, and take your virtual machine for all the hard work that you have done. Okay, so you can just store it for future reference and just get back to your system again. Okay, so that is all I wanted to show you in this video. Thank you all. Thanks for watching this video, and you guys have a great day.